Hi there, welcome to Eduretics, where we make your high school life simple. In today's video, we're going to discuss equivalent expressions, and this is the part 2 of medium difficulty for equivalent expressions. So if you want to start out with the topic, I would suggest you go to our previous videos and begin with the beginner's level. Or if you've already established concepts and you want to practice further, this is a perfect start. Okay, so let's look at the first question for the day. And like I've always said, whenever you see the new question, try it out first and then only look at our solution. Okay. So which of the following is an equivalent form of 1.5x minus 2.4 squared minus 5.2x squared minus 6.4? So upon first look, the numbers definitely don't look so friendly. But whenever you're faced with such questions, take a few seconds to see if you can identify some pattern, or if the expression is fitting into any known formula, any popular formula. For example, if you look at 5.2x squared minus 6.4, an initial idea, like you might be prompted to think that this might fall into the a square minus b square category, although I don't see 5.2 falling in as a perfect square. So since nothing is coming on top of the mind yet, so we would rather go with the safe method of doing the plain and simple expansion. So let's look at that. Okay. So 1.5x squared. So sorry, 1.5x squared, then plus 2.4 squared minus 2 times 1.5x times 2.4, and then minus 5.2x squared plus 6.4. Nothing complex in this. We just opened this bracket, the second one. So negative 5.2x squared and negative times negative 6.4 is positive 6.4. 1.5x squared, 2.25x squared, 2.4 squared, 5.76. It's advisable that you keep the squares and square roots of the first 20-25 numbers on top of your mind. So that would be helpful in reading your speed. Minus 2 times 1.5x times 2.4. 2 times 1.5 is 3. 3 times 2.4 is 7.2. 7.2x minus 5.2x squared plus 6.4. Let's go ahead and simplify. 2.25x squared minus 5.2x squared. That is negative 2.95x squared. 5.76 plus 6.4 comes out to be 5, 6, 11. 7.7.4 is 1.1. 12.16. And then the 7.2x, there's no other term with the variable part is x, so it remains independent, minus 7.2x. This is our final expression. And let's look at the options. We can very clearly see option C is the correct one. Okay, so in this question, we did not apply any trick. It was plain and simple, straight expansion. So sometimes you might need to do that as well. Okay. Let's look at the next question. Which of the following expressions is equivalent to x squared minus 5? Okay. Would say a fairly simple question. X squared minus 5 is the given expression. Now 5 obviously does not appear like a perfect square, but if you look at the options, so the examiners are open for a square root as well. So this is pretty suggestive of the fact that we might need to use that identity here, a squared minus b squared, which expands to a minus b times a plus b. A very important and very popular formula. A lot of questions might just be solved straight away using this formula. So in our case, x squared minus 5, let's break it into an expression like this. So x squared minus square root of 5 squared, because square root of 5 squared is going to give you a 5. Now this will fall into this identity a minus b, a plus b, like this. X minus root 5 times x plus root 5. This straight away suggests that option C is correct. So pretty straightforward, provided you have the identities, all the identities on your tips. So for example, the a minus b squared identities or a plus b squared or a square minus b square. These identities must be at the top of your mind so that you can straight away identify wherever they're applicable. Okay. Let's look at the next question. If x squared is equal to a plus b and y squared is equal to a plus c, which of the following is equal to x squared minus y squared raised to the power of 2, or whole squared? That's what we say. So in this question, they want us to actually solve these expansions and see what the final expression is for us. So this is a very standard equivalent expressions question, and you have to be very careful with the terms and the signs, because this is going to be seemingly it's going to be a long one. Let's see. So, and we'll try to do it in as much short as we can. Okay. X squared is equal to a plus b. Y squared is equal to a plus c. Remember, not x is equal to a plus b, but x squared is equal to a plus b. They're asking x squared minus y squared whole squared. So initially I also made this mistake. I was assuming this is x is equal to a plus b. That's why I said that this could go long. But now upon further inspection, it looks pretty clear, straightforward. X squared minus y squared whole squared. This is what we need to figure out. X squared is given to be a plus b. So a plus b minus y squared is a plus c. A plus c. This whole squared. Okay. So a plus b minus of a plus c. So minus a minus c. A and minus a get cancelled. B minus c squared. There's going to be b squared plus c squared minus 2bc. B squared plus c squared minus 2bc. That's option B. So as you can see, this turned out to be the straight opposite of what we assumed in the beginning, that this was going to be a long question. It's not at all a long one. Instead, it's pretty straightforward, provided you be very careful when you look at the expressions given. Okay. Let's look at the next question. The expression 24 upon 6x plus 42. If it's not very clear on your screens, let me write it here. 24 upon 6x plus 42, since they've written in a very small font, is equivalent to 4 upon x plus b. That's what the question claims, that it's equivalent to 4 upon x plus b, where b is a constant and x is greater than 0. What is the value of b? Okay, so they've given one expression, they've told that it is equivalent to another expression, and then they're asking the value of a certain constant which is unknown in one of the expressions. A classic case, a classic example of comparison questions where we need to compare the two sides. Okay, so on the left hand side, it's a 24 on the numerator, it's a 4 on the denominator. Okay, it's a 4 on the numerator on the right hand side, sorry, not in the denominator. Okay, now in the left hand side, in the denominator, 6x plus 42. In the right hand side, it's x plus 6. Sorry, x plus b. X plus b. First of all, the first hint which you get is you need to actually exploit the fact that they're equivalent. You need to make them seemingly equal. For that, as you see here, it's a 6x. Why not we do a 6x on the right hand side as well? So multiply and divide with a 6 on the right hand side, so that nothing changes, but the expression is manipulated to match the left hand side. So the left hand side stays the same. 24 upon 6x plus 42 is equal to the right hand side. 6 times 4 is a 24 upon 6 times x plus 6 times b. Now you see they fall into exactly what's required. So 24 is equal to 24. 6x is 6x on both sides. So that means 42 is equal to 6b. That's the comparison you need to do. And from here, b is equal to 42 over 6, which is a 7, a clear 7, which is option A for us. Okay, so this was a standard question on comparisons. And you'll find a lot of such questions coming with the topic equivalent expressions on the SAD. Okay, so make sure you practice these questions well. If you need this worksheet to practice on your own, you can head to our website eduretics.com, and from there you can head to the section of free resources. You'll get all the worksheets available. Okay, so like, share and subscribe our channel to get more such interesting informational videos through which you can prepare for your SAT. Okay, thanks, signing off.